So a hospital has been tracking the number of incidents of heart disease it treats each year for several years. The data is shown below. The data is approximately linear. Use the data from 2012 and 2015 to find an equation for linear model. And again, since it's asking for an equation here, we are looking for slope-intercept form. So the only two things we need is the slope and then also the y-intercept. Now it does say that year zero here should be 2010, right? So you'd say, well, 2011, 2010 right here, but we just don't know what those values are, although we could kind of figure those out. Now, it did say also that we just want to look at 2012 and 2015 to make this conclusion, okay? So that means that I'm going to go in here, and I just pretty much need to ignore these two values right here, all right? Is it always going to be linear? No. But if things stay approximately the same, then it should be approximately. You should see a rate of change that stays approximate, okay? So that means that we're looking at two ordered pairs right here. This would be 2012, 74, and then this one would be 2015, 92. And since we only need two things to write the equation, one of those, of course, is slope, and we just found two ordered pairs that we can use on this. So I'm just setting up the slope formula right here. I'll say that this is x1, y1. So putting these in, the x value is 2012, and the y value is 74. And then we'll say this other point here is x2, y2. Okay, and remember the order doesn't matter because the slope, the steepness of the line won't change. The x value 2015 and the y value 92. Now if you're wondering how I know that the x values are the year and the y value is heart disease incidence, because the x usually is always going to be time, and years is still a form of time. So this now, we're going to go and put this into the calculator. Yep, so the slope here, yeah, it is, see if we can get this working there, 6. Now, again, this in context would indicate that it increases 6 incidents every year, or for every year you get approximately 6 heart disease cases. So the slope, there's our first thing that we need, and we found it. And so the next thing we need is the y-intercept. Now, there's a couple different ways to find the y-intercept. I used slope-intercept form to do it last time we saw it in a problem. I'm going to use point slope form, which would have been part of 3.7 on this one, which shows, at least the way that I do it, y equals mx minus the x value, and then it's usually plus the y value. So the m value here, and then we'd have x value and a y value here. All right? So in green, I'm going to use the x1 and y1 values just because I already made them green. But we do know the slope already is 6, so I'm going to replace m. M is always slope. M was 6 right here. And then the x value in green there, if I can choose the right option here. I forgot one thing on this, actually. So 2012 is not actually the year. Now, it will still work with the slope, by the way, but for the y-intercept, it's not going to work. Because they say that 2010 is year 0, which really means that the year would be year 2. So 2010 is 0, 2011 1, 2012 is 2 on this. So it really reads as 274 like this. If you put 2012 into point slope form here, it's going to give you something that's really jacked up. Always be aware, I mean, that's what I just forgot right there, right, is that it's always relative, and it'll tell you how relative it is right here, like 2010. So the x value is 2, and the y value is 74. And then all we're going to do now, and this is not really solving for the y-intercept, although it pretty much is. You could say, look, we're going to go ahead and distribute here, which is true. 6 times x is 6x. 6 times negative 2 is negative 12. Then you still have the plus 74, right? So negative 12 plus 74, that'd be plus, looks like 62. And just to make things look pretty, there's our slope as 6, and then 6x. And I guess they did say to use n of t right here, so that's what I'll do. N of t, which means the x value is a t, the x is just a t. T for time, of course. So there's I don't really need parentheses. 6t plus 62, and this would be the linear model for this situation, at least between 2012 and 2015. So just we see this other ordered pair translated, 2015 would be the 5th year, and then the number of heart disease cases, 92. All right, so this also means if you went back to the slope formula, by the way, and you put 2 and 5 right there, yeah, it will maintain the same slope.